Alright guys, so today's gonna be a little bit different. So today, we are gonna go on a virtual field trip. Yay! Alright, anyways, so we're going to the Perot Museum in Dallas. So of course I couldn't take you guys with me. I tried the video with me in it there, but it was just too many kids and too much loudness, so I just decided to just voice over the actual video. So we'll be reviewing all the evolution stuff and kind of just looking around at some of the cool things they have to offer. So let's get started. Alright, so we started our adventure in this big hall, and there was like tons of really cool dinosaurs. Of course, the big T-Rex at the beginning with some sort of flying dinosaur. I don't know all the names of these guys, but I highly suggest you go check it out yourself. But really look at the bones and the structures and how they're similar to all these different things we were talking about. This was just cool. I don't know if how many of you guys saw Jurassic Park, but my husband and I are very huge fans. And it's the model of the Jurassic Park T-Rex, obviously the best part of the whole movie. So we're gonna start at life before, then, and now. So we're gonna be looking at all sorts of things, like they hit on different adaptations, and how they were different modern clues to ancient life. So you can read that if you would like. You can always pause it if you'd really like to read it. I just thought it was really cool information. So let's get started. So obviously that's a big footprint. Well, not so obvious. I thought it looked kind of like a crater. But you know, it was still pretty cool. But you know. So here's some more information. It was talking about ancient animals left behind very little evidence. And the only way that we can really try and figure things out is by looking at animals in the present and the past. So present animals with big feet typically step in a certain way, and we assume that the animals from the past would step in the same kind of manner. So while we go around, I want you to really look for those homologous structures. Remember, the structures that are very similar in all these different animals in the past and the present. So of course, we're looking at the leg bones a lot of times. Leg bones are very typical. This actually came from a T-Rex, which obviously is one of the cooler dinosaurs. So if you want to read, again, any of these signs that I go a little slowly at, you can always pause and read. They have some really interesting information. And if you ever get a chance, you should definitely go visit. It was really, really cool. So I want you just to really focus on homologous structures. So see, we got the leg bones and the pelvis. And it looks the same on both those dinosaurs we have right there. You can also even look at adaptations. So one's a predator animal, while the other is a prey. That's what they are showing actually on this exhibit. The difference between predator and prey. The prey having the eyes on the side and things for defense, while the predator has the sharp teeth and claws and has the eyes in the front of the face instead of on the side. So there's a bunch of different really cool dinosaurs. Like I said, this place was huge. I've actually never been to a museum with so many different bones and structures. So I really highly suggest it again. But if you look at, I don't know if it was a pterodactyl, it was probably something else, honestly. But you can see that it has a lot of the same structures that modern birds have. There was also different footprints and different bones that really, if you were to just find one of those, you can tell that they're very similar to bones we have today, like the vertebrae in the neck and the back. Those are all very similar to animals we would have found. So this one actually came from a predator that was in the Arctic. Again, I don't know the names of these, and I probably can't pronounce them. So I'm not gonna try, but I do suggest taking the time and reading some of these if you're really interested. But this one was actually found up in Alaska. So in this part of the museum is talking about the niche or the animal's place in the environment, just like we talked about in ecology. Except this is talking about prehistoric ecology. So that was very interesting. They do base it on ecology we see today. So it is talking about the different eyes, and the dinosaur that you just saw has really big eyes, which makes them think that it was nocturnal because having the smaller eyes versus the bigger eyes are going to be able to better to see at night. We also talked about being able to compete for mates. So there's different structures the animal would have. So the moose with the big antlers, and the ibex also with big horns for smashing against each other. It does have close-ups of those. And then they compare it to some dinosaurs. So different, they look similar to Triceratops, but that's not what they were called. Again, I am not a dinosaur person. I don't know the names, and I apologize for that. But you can see that they theorize, because of looking at the prey animals that we have today, that this was used for defense and also for attracting a mate and the possibilities. So there's the signs on those two different dinosaur skulls. So again, if you want to read these signs and you're really interested, just feel free to pause it. I mean, that's why I took the video of the signs. You should be able to read it if you have your thing in full screen, I would hope. But as you can see, it looks a lot like the moose antlers and the ibex horns in the way they're positioned and on the top of the head. It's very plausible that they use these to help attract a mate. And then different animals had different structures. But you can see they were all very similar in how they were formed. Alright, here we are again looking at some different prey animals. Like I said, they all have different adaptations, and that's what I was looking at in here, was adaptations, comparing adaptations from animals that we know and can actually study in real time, and comparing it to the bones and structures of the animals that we are no longer with us, so the extinct animals, and you're able to kind of determine, okay, so this one had flat mouth, so it's probably a herbivore versus the one with the sharp teeth, right? Alright, so here is a fun game. Me and my husband played against each other, so you were able to choose your adaptations. Of course, he got to be the predator, and I was the prey animal. So I chose that it had the stinky, foul smelling to deter quills and mimicry. So remember, mimicry is mimicking the environment or mimicking a poisonous animals. So he chose sharp teeth, wings, and tentacles. I don't know what kind of animal these are, that's just for fun. So the sharp teeth versus the stinky, and then they obviously fight. And I didn't do so good at this, and I was really upset because that wasn't fair, because I got gypped. I should have been allowed to be the predator. So obviously the predator won against me. And round 2, quills against the wings. Again, I tried so hard. All I wanted to do was win one round, and then the wings and my stupid quills didn't do nothing. I thought it would have stabbed the bottom of his feet, but what do I know? And then the mimicry versus the tentacles. I don't know why he was able to see me with tentacles. It really, to me, doesn't make a whole lot of sense, but he did. And unfortunately, I got gypped. He won against me, and I was super upset. So, yeah, gypped. But it was a fun little game, just practicing using different adaptations against different animals. So here we're looking at 2 similar species. So we actually got a bison from real time, and then it's an extinct version of a bison. So these 2 species probably are related and probably evolved from each other. You'll notice one is a lot larger than the other. We also got a giant beaver. Now this doesn't give it perspective, but that thing was huge. It was like almost the size of like a German Shepherd. It was big. We then got a mammoth. You'll notice the structures are very similar to elephants that we have today. But you'll notice those homologous structures again. See the rib cage and the femur and the tibia fibia. They all are very similar, even though they're different animals. The vertebrae in the back, those are all homologous structures, right? Alright, and here we have our little weirdo. This is how they would actually find it, all crushed on the rock, and then they rebuild them in the forms that you see. But you can again see those structures that look very similar to the structures that we talked about that all these different animals have. Now we've discussed a little bit about genetic drift. Here it's talking about actually the land bridge, but this would cause genetic drift because one species would cross to the other side, and if that bridge disappeared, like say a flood, those species would no longer be able to interact, which would cause a rift in the specification. Alright? So here we have some different sea animals, and how they changed over time, just different fish and stuff. And honestly, fossilized fish look a lot like the fish we have today. The only real difference is just size. The fish that are seen seem to be a lot larger. We also had this giant sea turtles. My favorite turtle is the sea turtle. So seeing these giant fossilized sea turtles was amazing. Like, you could have ridden it. But if you look again, the structures of the animal really didn't change all that much. Just how big it was is what changed. They have the scutes, they have the ribs inside the shell, the plastron, and all those different homologous structures, right? So we got the hands and the finger bones, the ribs. You'll see those vertebrate columns look just like a vertebrae. You got the hip with the pelvic girdle, and the feet with the foot bones, just like what we would have, just a bit on the larger size, obviously. Again, if you want to read about these guys, they have some pretty cool information. I really liked this guy. I thought he was really cool. They're actually thought to be related to like monitors, which I thought was really incredible. So we got some more fishies. Again, the fish look very similar to what they would look like today. The same physical structures are all there, except for size. And even some of the animals, they're the same size they were millions of years ago. So the animal really hasn't changed much. But as you can see, all these animals that are shown, if you're really looking at the bones, have a lot of the same bones. So that's why we think they all come from a common ancestor somewhere, right? They didn't have a monitor skeleton. I think it's supposed to be a savanna monitor, but they didn't actually specify what species of monitor they had. So we're actually going to watch this video. It's pretty interesting.
Technology or astronomy or paleontology, wanting to understand how things work, how things are put together. I was exposed to the outdoors and found fossils, but that wasn't a huge focus growing up. When I left school, I actually joined the Navy, the submarine service, took a career there in technology, moved into engineering, working predominantly with computer technology, doing both the hardware and software design. I started doing a lot of hiking and camping, and we started finding fossils. That just developed into a passion and started doing more formal research. And a few years ago, I had the opportunity to move full-time into paleontology, and here I am today. In the late 90s, I had an opportunity to visit Hebrew University in Jerusalem, and was going through the drawers and recognized some material in the drawers that had not been described, that I recognized as early mosasaurs. That went on to, in fact, be the oldest known mosasaur. Mosasaurs are related to a group of lizards that is still alive today. Some of the representatives you may be familiar with are, for instance, the Komodo dragon. Here's a skull of a Komodo dragon. The ancestors of mosasaurs were actually very similar. They had complete limbs, walked on land. But about 98 million years ago, they found their way back into the ocean, and over the course of 30 million years, evolved into animals that you see over my left shoulder here, some approaching the size of a school bus. The mosasaur exhibit at the Dallas Museum, it's a snapshot of mosasaur evolution. What they do have is a nice sample that shows kind of the early evolution of the group, Cephalosaurus and Dallosaurus, which are representatives of two different lineages that came up very early in the evolution of mosasaurs. And then more derived forms, like the very large Tylosaurus proriger. If you go to East Texas, there's rivers that cut through these sediments. You can actually walk there today and find remnants of these animals. Part of the exhibit at the Dallas Museum, the Dallosaurus specimen, was actually studied using CAT scans. The skull of that Dallosaurus was found in pieces. All of those pieces were scanned, brought into the computer, and I did a 3D reconstruction inside of the computer of all those pieces, kind of a big 3D jigsaw puzzle. The CAT scanning technologies, laser scanning technologies, and the 3D printing technologies have revolutionized certain aspects of paleontology. It's not just working with established techniques, but it's developing new techniques, devise different methods of getting to the questions. When you discover something new, when you learn something new, you're creating knowledge. And that to me is very exciting.
Alright, so just like he said, we're going to look at the whole chain, right? So we got our monitor lizard. Now, I'm not going to be able to pronounce any of these names. But then we go into the next section where the animal still has the legs, but has now switched to a swimming form. But I noticed it has a really long tail, right? And then the tail gets really long, and it's, I guess at that point it would be flippers or fins have extended a lot. But you can really see the similarities in the skulls. Alright, so then we moved on. These are actually different animals. I forget what period. Sorry, I was trying to remember. But you can see they look very similar to today's herbivores. So you'll see that they have the grinding teeth, just like elephants or deer, or horses even have. Even though they're coming from massive animals that are completely different than what we're used to seeing. So this is almost like a rhino, right? Then we come to the carnivores. You can see those big fangs that are there, along with the carnassials, which are the cutting teeth. And then we got some omnivores, but mostly it was carnivores and herbivores. But you can see how a lot of these teeth and things are all very similar to things we would see today. Again, those homologous structures coming up all over again, right? So these were some of my favorite guys. And you can see that some of them had adaptations that allowed them to have big frills on their back or claws, or even different feet and different teeth for different kinds of food that they would be eating. So different adaptations. So it really just gives you a chance to really look at how many different things we have fossilized. So even like plants and different fruits and different leaves, all these things are fossils. Like it's just a rock with the imprint on it now. So we have the mollusks. These are ones that you actually can find in your own backyard, which is really neat. If you guys ever find one of those and you don't want it, feel free to give it to me. Oh, and then we even have some bugs, which I thought was cool. Like, look at that. It's a dragonfly, a freaking dragonfly. Like, and little mollusks. And then there's this really cool one. I think they called it a scorpion fish. To me, it looks more like a weird shrimp, but apparently it's a scorpion fish. And then a full crab. I think it looks almost like a blue crab, but who knows? And then echinoderms. You guys probably don't know, but echinoderms are things like sea stars and sea urchins. So that was a sea urchin you saw at first, and those are some brittle stars. And then these crazy looking things, they were actually like almost like a species of tube worm. So that they were called the sea lilies, as you could see from the board, but they were almost looked to me like those little tube worms that you would find on the rocks, similar to like barnacles. And then we got fish. So like I said, the fish looked very similar. The stingray was by far one of my favorites. I would definitely want that on my wall. Super cool. But again, those homologous structures are all right there in your face. They all look the same, just slightly different. This I couldn't actually figure out what that was, but apparently it was something. Like I said, this stingray was my favorite. You can see that it had everything that stingrays have today, and honestly was the exact same way that it was. So these are cool. These are actually fossilized eggs. So the first one is a dinosaur egg. Well, the middle one is actually a fossilized duck egg. So it says that it was an actual duck egg, which is very interesting to me because I don't know why. I thought like an egg would be too soft to be able to fossilize, but like we're always learning something, right? So again, if you want to read these signs, they are very interesting and it would give you different clues of things and what these all are. But as you can see, all these animals look very similar. You can actually kind of guess what they eat, where they're from, just from looking at animals we have today. So after we went from the dinosaurs, we actually went up to, it was a bird hall. And in this bird hall, they had a make a bird station. And of course, I had to take advantage because it was super fun. So I had to make a pin. And apparently, I am not very good at making a pin because I struggled big time. I wanted to write my name, but then it turned into colors for whatever reason. And then those colors just kept messing me up. So we actually went ST for Slack and my first name Tara, and yellow, and then flower. So we got to get to choose all the adaptations that our bird was going to have. So we got to first choose its body shape. So we had muscular, or streamlined, or round. I wish I could have just taken you guys like on a day and it could have been a live stream. I think that would have been a lot more interactive and fun. But I have to teach you guys, and I can't just go on field trips alone. So we got to do that, and then we got to choose some different feathers. And of course, as we were making the bird, we were wandering around looking at different birds. So this one actually went through the different, it was almost like an evolution of the bird. So we started with, there was actually a fossilized feather, which that was really neat because there isn't very many of those. It's very small and simple. It's just probably a feather that fell off of an animal. So we start, and it almost looks very similar to like the velociraptors we think of today. It has long claws, has very long stilty feet, but as you can see, they got that big cranium with the eyes facing to forward. Then there's this little guy, but you can see the start of wings. See how his fingers are slightly longer, but not long enough to make wings quite yet. And then we got this weird guy who is possibly one of the first birds. And then just different diving birds. And then we have the modern day pelican. And as you can see, it looked very similar to all the others. This is just the information if you want to read more about it. It's talking about how some dinosaurs are theorized to have feathers. So it was kind of estimating where the feathers would be based on different animals and how it would change over time. So then we finally found one of our other bird things. I put in my special secret code so I can make my bird. And we got to choose our wings. So we had different kinds. We had round and short, the forked one, and then we had broad wings and fantail, which of course I was like, yeah, we're doing that. We're gonna be cool. Like a predator. Also, you were able to practice flying, which was super cool. That is my husband. He was too busy flying to actually look over and say hello to the camera. But it was actually really fun. You got to like lean and flap and fly. I actually crashed hardcore. I am not a good bird. Here's a top view of those dinosaurs we were looking at earlier. As you can see they have the shoulder bones and the neck bones, just like we would have. Then we got our bird thing again, and I got to choose the feet and the beak. So of course I had to choose, but it actually messed up and it shut down on me. I was getting really frustrated because it kept doing its own thing. Me and technology have a very working relationship. But as you can see, we're getting to choose all the adaptations for this bird. So then we got to choose the food our bird would eat. Of course, my finger wasn't really working and it wasn't listening, but we did get it. So here we are, we get to choose our food. Plants and meat is what I chose for our bird to eat. Again, this one was not wanting to work. I got super frustrated, but I was gonna make my bird regardless. This is the sounds and calls, so I'll actually play the sounds on this. obviously I chose the obnoxious noise because what other option is there realistically? And then we were at the last one where we were choosing our feathers. And we got elegant and beautiful, we had fancy and ornate, and we had camouflage. And at first I was like, oh, I want camouflage. But then I changed my mind because I was like, actually, I want to be fabulous. So I chose the bright and colorful. Alright. And then we finally get to see our bird eventually. So we have our last one, yellow flower, and we get to name it. And I was just looking at all the different names. I couldn't actually type what I would want to call it, or else I would have called it something more fun. But I chose Majestic, and then I just wanted to see what was allowed, and it was all just kind of boring except for Zipper. So it's called a Majestic Zipper, and this is our beautiful bird. But then you can look at the different adaptations. So obviously its beak and feet are meant for eating a prey animal. And that's just kind of what you can look at. Alright, so then we moved down to our next hall and we had mammoth bones, which were really, really neat. This actually came from Texas, which I didn't know they could even be found around here, which I thought was really, really cool. We got some more fish bones and leaves and plants. And some of these animals look exactly how you would find them, which I just think is so cool, is how little sea life has changed, because you can find sand dollars and lightning whelks just like that at the beach today, but you can also find fossilized ones. Now the ammonites and stuff probably not gonna find alive, but there are things like nautiluses that are still alive that look just like them. And then this is a guy, I thought he looked just like a Komodo dragon, and honestly the bones on there, I honestly think if I found that, I wouldn't know what I was looking at. Really kudos to those paleontologists, because I wouldn't be able to see it. So this exhibit actually went through the time periods in order. So we got to start with, further away, there's that scorpion fish again, and sea stars. Yeah, so it just goes through the time periods, which was really nice. It's showing different plants and different areas of evolution and how it changed over time. I don't know if it all came from one area or if it was one of those things where they just found different ones from different places and put them all together, or if it came from one single spot. But as you go deeper, that's how they know it's from a longer period of time. It's typically from a deeper sediment than the ones on the surface. Oh, this guy's head looks like a Pokemon. I'm just gonna straight up say it. It looks like a Pokemon. Like, I don't remember what it was, but if I had found that, I would have thought somebody made it a 3D model of it. So it's just fun to look at all this stuff, because it is things that used to survive in our world. And look, even bugs. Like, I think it was some sort of, it looks like a locust, but some sort of grasshopper. And that's actually a pine cone that has been split, which was really neat. But yeah, it's really cool. I know I've already said this like 100 times, but you guys need to go. It was so neat. I wish I could do a field trip there with you guys. It was a lot of fun, and I really enjoyed it, but I'm also a nerd, so who knows, you guys might not enjoy it as much, but it had some really, really cool stuff, and if you have little cousins or siblings, they would probably really like it too, or if you're like me and my husband and like Jurassic Park. They didn't have mosquitoes in Amber though. So we then came to our last part. There is more to the museum, but this is the last part that I videoed. And it's just showing the different sloth bones and then talking about DNA. So DNA is going to be a section we're going to have later, but it talks about how the pufferfish has DNA close to our DNA. So that's it for now. I hope you guys had a good time. I'm sorry I didn't get better video. Maybe with more practice, I can do better virtual field trips. So you guys have a great day, and if you have any questions, feel free to ask.